Imagine a place where your breath freezes mid-air, cars must run all day or risk never starting again, and winter doesn't last a few months, but most of the year. Welcome to Siberia, one of the coldest inhabited regions on Earth. But why is it so cold? What scientific forces keep this vast region in a frozen grip for most of the year? In this video, we're going deep into the science behind Siberia's bone-chilling cold. From geography and atmospheric dynamics to the frozen ground beneath your feet, get ready to uncover the reasons behind this icy mystery. To understand Siberia's frigid climate, we have to look at where it sits on the map. Siberia spans almost all of northern Asia, covering over 13 million square kilometers, about 77% of Russia. But here's what's crucial. It's located far from the moderating effects of oceans, lies at high latitudes, closer to the Arctic Circle, and has vast, flat terrain that allows cold air to settle and stagnate. Siberia stretches from the Ural Mountains in the west to the Pacific Ocean in the east. Most of it lies between 50 degrees north and 70 degrees north latitude, meaning it's positioned to receive very low solar radiation, especially in winter months. In December, many parts receive only a few hours of sunlight, or none at all. One of the strongest reasons Siberia is so cold is due to its continental climate, a type of climate found deep inland, far from the sea. Unlike coastal areas, which enjoy the heat-retaining properties of oceans, continental interiors lose heat quickly. This means Siberia doesn't benefit from the thermal buffering that oceans provide. Once winter begins and sunlight fades, there's nothing to stop the temperature from plummeting. The land loses heat fast, and the cold air remains trapped. The result? Temperatures can fall below -50 degrees Celsius, -58 degrees Fahrenheit, in many Siberian towns and villages during winter. Let's talk about the air itself. During winter, Siberia becomes home to a massive, dominating weather system, the Siberian High, a cold, dense, high-pressure system that forms over the region. Here's how it works. Cold air is denser and heavier, causing it to sink and create high pressure. This air stagnates, trapping more cold air beneath it. It prevents warm air from entering, creating a self-reinforcing bubble of cold. This system can cover millions of square kilometers and stay in place for weeks or even months, keeping skies clear and temperatures brutally low. Clear skies might sound pleasant, but they actually accelerate radiative cooling. At night, the Earth loses heat to space more rapidly, and without clouds to insulate, temperatures nosedive. Now let's shift from the skies to the ground. Beneath Siberia lies permafrost, ground that stays frozen year-round. In some areas it reaches depths of hundreds of meters, and while it may seem like just frozen dirt, permafrost plays a key role in Siberia's coldness. Why? Because frozen ground has very low thermal conductivity. When the sun shines during the short summer, the heat doesn't penetrate deeply. Instead, it warms only the top layer, called the active layer, which refreezes once temperatures drop. This means heat can't accumulate in the soil over the years. Siberia remains cold, not just on the surface, but from the ground up. Siberia's latitude also means the sun never gets very high in the sky, especially during winter. Even at noon, the sun hangs low on the horizon, casting long shadows and delivering weak solar energy. Combine that with the extremely short daylight hours, as few as 3 hours in some regions, and you get minimal warming, even on sunny days. The sun's rays strike at a shallow angle, spreading out over a larger surface area and reducing the intensity of heat delivered to the ground. Siberia's snowy landscape is beautiful, but it's also part of the reason it stays cold. When snow covers the ground, it increases albedo, the reflectivity of the Earth's surface. Snow reflects up to 90% of incoming sunlight, bouncing energy back into space instead of absorbing it. This feedback loop is powerful. Snow falls. Surface becomes more reflective, less solar energy absorbed. Temperatures drop further. More snow forms. This positive feedback loop keeps Siberia in a state of deep freeze for months at a time. Another icy trick of Siberia's geography is how it creates cold air pools, especially in valleys and basins. Here's what happens. Cold air, being denser, sinks to low-lying areas at night. In regions like Oymyakon or the central Yakutian lowlands, this air collects and gets trapped. Now add a temperature inversion. when warmer air sits above colder air, and the trapped cold gets sealed in like a lid on a freezer. No wind, no mixing, no warming. These inversions can last for days or weeks, causing nightmarishly cold conditions on the ground. Towns like Verkhoyansk and Oymyakon have recorded record lows below -67 degrees Celsius, or 88 degrees Fahrenheit, the coldest temperatures ever observed outside Antarctica. Siberia's proximity to the Arctic Ocean means it often exchanges air masses with the polar north. In winter, Arctic air masses expand southward and bring frigid air deep into the heart of Siberia. But here's the twist. Unlike the North Atlantic, the Arctic Ocean is mostly covered by sea ice in winter, offering no warmth to the air above. So instead of moderating the cold, the Arctic contributes to it, pushing even colder and drier air masses into the already freezing Siberian plains. Though much of Siberia is flat, areas like the Central Siberian Plateau rise over 500 meters above sea level. At higher elevations, the air is thinner and can't hold heat as effectively, compounding the cold. Add to that the geographical isolation. No warm air from the Atlantic or Pacific can easily reach deep into the region. Siberia is boxed in by mountains and distance, creating a climate that's self-contained and frozen in time. Here's the surprising part. While climate change is warming much of the planet, Siberia is experiencing extreme temperature swings, with hotter summers and still frigid winters. In fact, record-breaking cold snaps still occur. Some scientists warn that melting permafrost could lead to even stronger Siberian highs in future winters, making cold snaps more intense, not less. So, in a strange twist, the frozen legacy of Siberia may become even more volatile in the decades ahead. From its geographic position to atmospheric science, from permafrost to polar air, Siberia's bitter cold is no accident. It's the result of a perfect storm of natural forces, working in unison to create one of Earth's most extreme climates. So the next time you see a photo of a Siberian village buried in snow, or hear of temperatures so cold your eyelashes freeze, know there's serious science behind it. Thanks for watching. If you found this breakdown fascinating, don't forget to like, subscribe, and turn on notifications for more in-depth explorations of Earth's most extraordinary places.